actually companies.
What would we call this expression? What? Okay, an n-squared trinomial. It is a quadratic too, that's correct. Okay, but normally what do we do with these things? We factor, right? Factor this for me. We took a trinomial where the highest degree, or sorry, the highest exponent was 2, where it was degree 2, and we factored it into 2 binomials. We're taking it one step further now. We're taking a 4-term binomial, or 4-term polynomial, where the degree is 3. This is going to factor the 3 binomials. And that's going to look like x and then a number, x and then another number, or possibly the same, x and then another number, or possibly the same. But I need to figure those out. Unfortunately, we can't get this answer as quickly as we can get this one. We have to do some work on it. And the work that we have to do involves what we did in the last lesson on the remainder theorem, and something called the factor theorem, which I talked briefly about yesterday, that if you find the remainder of some polynomial by plugging, like if I said, you don't have to write this down, x cubed plus 3x squared minus 7x plus 5 or something like that, okay? And I want to divide by x minus 4. Okay, then if I plug 4 in here for x and calculate it and it equals 0, that means this is a factor. This is one of these. Okay, so that's how I actually started, is using the remainder and factor theorems. The first step, and we're going to use this example, x cubed minus 4x squared minus x plus 4. We're going to factor this, so it's going to look like this at the end. But I need to find one of these first. Okay, so I'm going to break it up. This will actually break up into a binomial times a trinomial. And then this I can factor to 2 binomials, which will leave me with 3 binomials when I do the whole thing. These 2 numbers, okay, remember, when I multiply a binomial by a trinomial, when I multiply the first terms in each, it's going to be that one. When I multiply the last numbers in each, it's got to be 4. Okay, so what I need to do is think of factors of 4. Because when I join these 2, they're going to multiply to get positive 4. What 2 numbers? Okay, 2 times 2, 1 times 4. Now this is where you got to think outside the box a little bit, because there's more. -2, -2, -1, -4. So that means the factors of 4, we would just write it like this: plus minus 1, plus minus 2, plus minus 4. It's going to be a combination of 2 of those. So what I'm going to do is I'm going to pick these, plug them into here for x, and see if I get 0 when I calculate. Because if I get 0, that means it divides evenly into it. So pick numbers. Like when you decide what you're going to try first, don't try the big numbers first. Try the smaller numbers. chances are you'll get one of the factors here and likely definitely get one of the factors if you have to go this far. So let's try 1. So that gives me 1 cubed minus 4 times 1 squared minus 1 plus 4. So 1 cubed is 4 times 1 squared is, and then minus 1 plus 4. Well, I've got 1 minus 3, or I get negative 3, negative 4 plus 4 is 0. That means A is 1. How do I write that as a factor? What do I put here? X, what sign? Minus, because it has to be in subtraction form, right? So x minus 1 is a factor. We've got one of them. Now I got to find the other two. And how I do that is I take this original and divide by the factor I just found. So divide this by x minus 1, which means A is 1, and we use synthetic division. 1, negative 4, negative 1, 4. Drop the first number and then do what? Multiply, then add. Multiply, then add. Multiply, then add. How do I know if I'm on the right track? This is where you can check and make sure. Yeah, remember, we know this should have a remainder of 0 because we proved it using the remainder theorem. So when I do the synthetic division, it should be 0. Now, how do I write the answer? Well, exponent is 1 less, right? So 1x squared minus 3x to the first, or just minus 3x, and then minus the number, which can be factored. You don't have to worry about trying numbers again. X. What do we got?
Negative 4 plus 1.
Negative 4 plus 1. There's our final two factors. So therefore, that would be the total or final answer. Or you can just write it at the bottom here. It would be x minus 1, the first factor we found, times the other two factors we found after synthetic division and trinomial factor. So that's how you do it. Okay. How many times you have to do synthetic division and the remainder theorem depends on the degree. Notice with degree 3, yeah, I'll be there a second. With degree 3, you're going to have to do remainder theorem once, synthetic division. If it was degree 4, you'd have to do it twice. If it's degree 5, you'd have to do it 3 times. Okay. Usually they're going to be cubes. Yum.
First, x minus 1.
Yep.
Do I go from x plus 2?
What's that? Sorry.
X plus 1.
This one here.
Yeah, that one.
Yeah.
Do I not change it?
Why would you? Sorry. Why would you change it?
Because for the other one, it was like this first.
Yeah. No. You wouldn't change it. Yeah. Because like, what does this tell me here? This tells me. Here's the answer again. If I try 1 and the remainder term, it's going to work. If I try 4 and plug it in for x here and calculate it, it's going to be 0. If I plug -1 into here and calculate it, it's going to be 0, because these are all factors. Does that help?
We tried like 1, right?
Yeah. I just picked a small number. Well, if it's a factor, yes, because remember, the binomial has to be always written in the form x minus. So if I try 1 and it works, I got to go x minus 1. If I try -1 and it works, then I got to go x minus -1, which changes it to plus. Yeah. Okay. I want to try a couple more of these. So it's going to break, this one's going to break up into 3 binomials. Why? Because the degree is 3. I need to find one. So I need to try a number that is a factor of 6. What are the factors of 6? Sorry? 1.
Plus
Minus 1. Plus minus 2. Plus minus 3. Plus minus 6. So I want to start with a small one. Okay. So if I'm looking at this, and if I try 1, I know it's not going to work. How do I know it's not going to work? Because this is positive, this is positive, this is positive, that's the only one that's negative. That's not going to get me to 0. So we'll try it anyway, but sometimes if you just look at it, you might be able to see, no, it's not going to work. 1 cubed minus 4 times 1 squared plus 1 plus 6 is 1 minus 4 plus 1 plus 6 equals 4. Doesn't work. So we could try -1. We could try 2. I'm going to try -1. So now it's going to be -1 cubed minus 4 times -1 squared plus -1 plus 6. I think that one's going to work out. Maybe. -1 minus 4 minus 1. Oh, yeah. Nope, it doesn't. Sorry. They canceled out. I was close. So this one works out to 2, doesn't work. What do you want to try? Remember, don't try the big ones yet.
2.
Yeah, okay, let's take 2 a shot. It's got to be 2 or -2. You'll find that you'll find these pretty quickly once you practice with them. This one looks promising. 8 minus 16 plus 2 plus 6 does equal 0. So, yeah.
For -1, is it -1 cubed -1? Don't cancel it.
What's all right. Yeah. Yeah, you're right. So that means -1 would have worked. Okay, so I messed that up. So I'm just going to forget about that and I'm going to stick with this one. So what's the factor that I found? How do you the whole thing? X minus 2. Now, to find the other factors, I already know x plus 1 is going to be one of them. Divide this by this using synthetic division. So 2 1 minus 4, 1, 6. That's going to give me a remainder of 0. Drop the 1 times 2, add. Times 2, add. Times 2, add. What do I get for trinomial? Which can be now factored. So there's my 3 factors. X minus 2, x minus 3, x plus 1. Write your final answer. Okay, don't just stop there. You have to write the factored form. That's your final answer. Okay, I want you to go on the last one. This one's going to have quite a few factors to try, but again, try low. Calculations are easier. Chances are you're going to find one sooner than later. Did you find one that worked? What worked? 2? Cubed minus 2 squared minus 8 times 2 plus 12. 8 minus 4 minus 16 plus 12 gives us 0. That means x minus 2 is a factor. So that's one of them. Now we take the original polynomial, divide x minus 2 using synthetic division. 1, negative 1, negative 8, plus 12. Drop the 1 times and add. And that translates to? Anybody?
X squared. So that's
Which factors to?
X minus 2.
So there's our 3. 2 of them which happen to be identical. So therefore, our final answer would be x minus 2 times x plus 3 times x minus 2. Or, and that's correct. You could get a little fancy if you want and do x minus 3 times x minus 2 all squared. But this, to me, is still correct. You don't necessarily have to write it as square, although it will be helpful come graphing time, which is actually the next and final lesson in the unit. Okay? Okay.